So thanks for coming. So this is poking holes in the cloud. You can see I like cats. So I'll tell you a little bit about my background, and also I found this picture online. I thought it was pretty cool. Someone actually did some cosplaying with their cat, and it's got like the Hack the Planet poster in the back, stickers on the laptop. Thought it was pretty awesome. Typical hacker cat wearing his hoodie, hacking. So about me, a little bit of my background. I'm a security researcher for Cisco. I'm actually based out of San Antonio, but some of my colleagues are here in Austin. I'm always learning, and so I think in the security industry, which y'all are probably involved in some way, shape, or form, you have to be always learning. I mean, things are constantly changing, features keep adding, and so it's I'm always learning, and so I never pretend to know it all. I'm an experienced script kitten, so it's kind of a play on words. From the old terminology of being a script kiddie, someone that just runs exploits and stuff like that. I don't really consider myself an exploit developer. I've written some before, but that's not really my specialty. I'm more specialized in taking known techniques out there and applying them to basically do pen testing and auditing of security of different environments. More often lately, it's been AWS. So I'm pretty new to DevOps. I've been a developer before, but I'm kind of learning as I go when it comes to DevOps, because I feel that I need to know more about DevOps and participate in it to really understand what the implications are of what I'm testing and how the environment's put together and why it matters. So feel free to laugh with me, laugh at me. I'm probably going to say some wrong stuff. It's very possible. I'm going to try to make time for questions at the end. And if I don't know, I don't pretend to know stuff. I'll tell you I don't know, and there may be stuff that you would be able to tell me. So feel free to correct me. And all thoughts and opinions are mine and not my employer's. So that's my Twitter, a little security. I don't tweet a lot of original stuff, but feel free to follow me. I do follow a lot of people and kind of aggregate a lot of stuff that I see online. All right, so about the topic, as you heard from the intro. So the pen tests that I've been doing over the past few years, they're usually 1 to 2 week pen test, and I was beginning to find that, there'd be new technologies, which happens a lot of time, right? Like developers are writing software, it could be off-the-shelf software, it could be custom code, but I was running into applications and systems that I'd never seen before. I came from the traditional pen testing background where it was a Windows network or some Unix host or maybe an external system. And when I started to look at more AWS hosted systems, I started to realize that, these old tools and techniques aren't working. The same way of doing it, the same tools we had, using Nmap and Nessus, you can still use some of those tools, but you have to use them in different ways. And so I started talking to people, started looking at some of the big players out there that are hosting AWS, people at Netflix, and talking to them about security. And I even asked one of them, I was like, is pen testing still relevant in this world? Because I feel like, when I was seeing a lot of these environments, it was just, and I'll get to it in a minute, but it was just basically 80 and 443 running. And so, I started asking, and the answer was, from them at least, pen testing is still relevant, you just have to do it differently. And so that's kind of where I came to this talk from. And obviously I couldn't share actual findings, but I'm going to talk about some of the stuff that I found in the work that I've done over the past year or so. And IP addresses and names have been changed to protect the guilty or innocent, depending on how you look at it. So some of y'all might know about pen testing, have some idea of it. I'll give kind of a quick overview. Won't spend too much time on that. But essentially, there's different types of pen tests you can do, right? So you can do black box pen tests. Typically, if you're a consultant, you're going to an environment and you're delivering a black box pen test. The client's not giving you information. They're not giving you access. They're just saying, here's the name of a company, hack this. And of course, you get permission, right? And so white box pen testing, some people do like source code assisted, where they're given source code, they're doing code review, and then they're going in and saying, okay, they're actually standing up an environment and then with that code that they're given and then trying to pen test it, kind of like in this sandbox, right? And so gray box testing is somewhere in between. So maybe you're given authentication credentials for a web application, you're doing a web app pen test, and so it's kind of a gray box pen test. They're not expecting you to, do all the user enumeration and bust into an account to be able to test the application. They're typically giving you access, and sometimes even administrator access, so you can see all the features, and you can look at the features of the app and then say, maybe as a lower level user, try to escalate your privileges or try to do something that way, right? And so also, a lot of people, it confused me at first, the security in the cloud versus security of the cloud. So security of the cloud is actually pretty solid, right? So like, especially AWS, they spend a lot of time, poking at their own systems. Of course, as they're rolling new stuff out, things could always happen, but for the most part, the security of the cloud is pretty well documented. It meets many standards, ISO, SOC standards. It meets all these different standards. It gets pen tested all the time. It's looked at all the time. But security in the cloud is really what this talk is about, and it's about developers and users standing up their applications and their environments in AWS and how to look at those, right? And so security auditing versus pen testing, right? This type of auditing, it's not the typical, checkbox auditing. Are you, using two-factor? Are you doing this? Are you encrypting your data? It's more like looking at it. Think of like a pen test plus. Like you really want to look at it more in depth, and so you're doing a more thorough security audit, right? And the focus is still what is useful to an attacker, but thinking of it in a different way from a traditional pen test is good because, in my opinion anyway, I think you get a lot more value looking at it from the inside and the outside. So, especially, in AWS and other cloud environments too, you kind of get back to this corporate, model where they had this secure perimeter and then all the apps inside were, not even looked at because, we have a firewall and the only ports open are 22, 80, and 443. And we know how that usually ends. It's this idea where they have a virtual private cloud with this hardened outside and then all these things, DevOps-y things running inside. And so that's kind of what we're going to look at. And so, again, AWS releases more features every year. IP addresses change rapidly, right? Auto-scaling up and down. And so how do you test this rapid automation of systems that are scaling up, scaling down, being orchestrated, containerized, microserviced, all these things that are happening? And so keeping up with that automation, I felt like and apparently I'm not the only one, because as you'll see as I go through a lot of tools in this talk as well, so you can refer to it later. And I'll share the presentation. It has links that you can look at, because even for my own reference, it was really useful to have. So I think the way to do that, to keep up with this automation, is to automate as much as possible ourselves. So as pen testers, as security professionals, we really need to start automating some of this stuff as much as possible to provide coverage for all these different features. And attackers are doing this too. Attackers are automating stuff. Attackers are looking for vulnerable systems in an automated way. They're going out there, they're scanning. They're looking at Shodan, they're looking at Project Sonar data, they're looking at all these internet scans. You can scan large amounts of IPs now from DigitalOcean or AWS even, and in a small amount of time. Scanning technology and processing power has really enabled that. So wanting to emulate how attackers are doing this in real life and not just looking at the outside. So what's different about a normal versus AWS pen test, right? So it's not your typical network or application pen test. Typically, right, and this depends, but there's little to no Windows footprint. So it's not like you're going to have an Exchange server running out there with Outlook web access on the perimeter. You're only going to usually see 80 and 443 exposed externally, and those might actually just be like a load balancer. You may not be able to hit the origin servers or anything else. And so in a traditional pen testing model, okay, 80 and 443 apps are running. I don't have a login. I don't know what else you want me to look at, right? So Attackers aren't going to do that. Attackers aren't going to follow the scope restrictions. They're going to dig as deep as they can. They're going to try to, phish you. They're going to try to pop developers' accounts. They're going to try to do anything they can to try to get into that interior environment. And so that's why I recommend a gray box approach, because instead of just telling your pen testers, hey, look at the outside, and if you want to get a checkbox on your pen test and just continue on, that's fine. Don't give them any information. But if you want to get more value out of your pen test, set up a Bastion server or something inside your environment to start looking at stuff, because as you'll see in a second, it's only a matter of time in some cases, or a matter of misconfiguration, or a matter of something else happening, credentials leaking. Somebody turns that external pen test into an internal one, and you're not going to have that layered security, that defense in depth that you really need, because nobody's looked at that stuff inside. So again, I was coming into these, getting assigned these pen tests and doing them over and over. I started seeing new technologies that were coming out and things I had never heard of before. I'm like, what is this Kubernetes? What is this, what, serverless app? The app doesn't have any servers? Like, what, GraphQL, DevOps, DevSecOps, NetSec DevOps. So I have actually created a new word for everyone today. And behold, Pentest NetSec DevOps. This is basically a combination of pen testing, network security, and DevOps. So, half jokingly, but it would be hilarious if people start using that. So, the process, right? Every pen test requires permission, otherwise you're just hacking. AWS has a special form to be filled out. A lot of you have probably seen this. You fill out the form as an authenticated user. You have to specify your source IPs. Otherwise, they might flag your traffic, right? And they only permit testing of certain AWS resources, because I'm seeing also a lot of apps that are built on, you can build an entire app just on AWS without having any servers. You can use Lambda, you can use RDS as your database, you can use, EC2, but you don't even have to, right? And then I saw Lightsail recently, and I was like, Lightsail, what is that? And it's just like no frills EC2, and it actually runs on EC2, but they hide all the complexity for you to make it easier for people to use AWS for their servers. So like for $3.50 a month, you can get an Ubuntu, Lightsail instance or whatever. So these are the things that they permit: CloudFront, Aurora, API gateway, stuff like that. And so other than that, you're not allowed to test any of the AWS infrastructure. So in any pen test, I typically, I was taught this back in the day. There's different methodologies. So this is kind of the methodology that I use for pen testing, right? And so it's a 4-phase methodology. Basically, you start with reconnaissance. So reconnaissance is information gathering, looking at stuff. Again, to the original example, if you're doing a black box pen test of a client, you're going to look up their IP addresses in ARIN. You're going to see what their external footprint is. You're going to see, who their users are. Maybe gather email addresses. You're going to, just gather as much information as possible about the applications and what's running on there, right? The next phase, vulnerability analysis, is when you really start to look at it. It may involve a vulnerability scan if it's a large internal network. If it's an external network and maybe you don't want to generate a lot of noise, it may be, slow and low type of looking at servers, fingerprinting versions, things like that, right? Saying, okay, well, they're running Tomcat XYZ. I know without even running a vulnerability scan, I plug that into CVE details, I can see all the bugs that that version of Tomcat has. So I can then go look, oh, hey, that's, exploitable, or I can try to, do further stuff. And so that's what takes us into phase 3. So phase 3 is where you're actually doing the attacking. So you're saying, okay, I'm going to try to brute force the Tomcat's manager's login. I see that the login was enabled, and they, so I'm going to try to just send requests until I can get a login to it. Then once that's just the first part, I guess. And then once you get into a system or gain a foothold of some kind, whether it's an email address, a login, any type of foothold, that's post-exploitation, right? And so post-exploitation, anything you're doing, trying to get more information, trying to steal user accounts, trying to get into further systems, trying to pivot, trying to look at the internal network now. And many times you'll end up back in phase 1, because if you've breached that external perimeter, you're coming into the internal network now, you basically start reconnaissance again. You want to see what's running, what services, what IPs, what do they have, and then you start the process again and keep going. So it's phase 1 reconnaissance. That's either really good Photoshop. I think it's just really good Photoshop. Because I'm like, there's no way they got a cat to hold those binoculars. But it's a perfect example of me reconnaissance. You're just kind of scoping it out. So traditional recon goals, right, might be gather information on the targets, IPs, email addresses, physical addresses, right, where their building's located, what type of access cards. Targeting their employees at Starbucks and seeing, they use this, system for RFID badges, whatever. Looking for points of entry, so people, buildings, networks, seeing where the smokers hang out. So you start gathering details, version info, key employees, DNS hosts, a lot of stuff like that. Well, with AWS, it's a little bit different. And so obviously you're not worried about the buildings and the employees, and it's just depending on the scope. But one thing I noticed kind of doing recon on AWS environments is there's a lot of information out there that you can find, like internal IP addresses. If sometimes, even if they're using a load balancer, some of the responses might contain like an internal IP address of whatever server's in there. So you're like, okay, I know they're using this IP address scheme in their VPC. You can do searches on S3 buckets. You can look at DNS information. And you can also look for other points of entry, applications, proxies, do the servers all listen on SSH to the IPs? Is there some kind of proxy in there? Maybe they, have this proxy externally available for some weird like microservice interaction or something, right? So gathering all those details, architecture, microservices, and code. The one thing about, I guess the main kind of cool thing about Recon or AWS is a lot of time just in looking, for information, sometimes you can even gather credentials like out of GitHub and stuff like that. So it's even possible to win a pen test just through basically at the recon stage. There's a few tools that you can use for doing DNS recon. Project Sonar is a really good resource. They basically scanning the internet all the time, collecting data, DNS information, other information. DNS Recon's a good tool as well, and I'm not going to have time today to kind of go into detail on each tool. I'm just kind of providing these as a resource for y'all to go and dig into. So you'll see a lot of tools in this talk. I only did that because I feel like that is one thing a lot of people ask, well, what tools do we use? But it's also a good starting point to go and dig into these tools and understand how they work, to understand how you could do that manually, but also like what they're doing and how they're finding the flaws and what the flaws are. So it's a good starting point. There's just tons of information out there. So for DNS Recon, I recommend that. It's actually called DNS Recon. And the Harvester. The Harvester's been around a while. It'll give you things like email addresses, domains, stuff like that. And so even though you're only given a certain set of IPs or domains, there may be other domains, other applications being hosted on the same load balancer that maybe give you different responses. Maybe there's a different way in to that same environment within the same application. As long as it's, you have permission for those systems, then it should be within scope. Nmap is still used for recon. You can run it externally inside a VPC, or you can actually run Nmap inside a Lambda function. So that's kind of an interesting thing that I came across was in some cases where if you can find either direct access to Lambda or like command injection, you can get Nmap running inside. So it's one way to scan insides as long as they're allowing it through ACLs. So it would be doing things like version scanning, looking for web apps, servers, stuff like that. So particular ports also that are different for AWS, like the Kubernetes API, maybe there's memcached open, things like that that are listening that I would start to see and go, what is this? I've never seen this before. And it's like memcached, I'd look, and a lot of people don't turn authentication on, so you start looking at it and seeing stuff in there. Message queues, things like that. So buckets. Buckets are a really fun thing to play with. There's a lot of publicly accessible buckets out there. Apparently attackers just scan these all the time. They just constantly look for either sensitive information, PII type stuff, but they also look for credentials. They look for anything on there. They just like constantly looking for anything that matches these regexes for like different keys and strings, SSH keys, anything they can find. And so there's a few scanners out there, and new ones come out. Some of the old ones are kind of deprecated, or they have too much use, so they start to limit you. But there's a few that you can run. S3 scanner was pretty good. AWS Bucket Dump was also pretty good. The newest one that I saw was Bucket Stream. And the way that it was looking for, and they all have different ways that they find the buckets. Some are just kind of brute force, some are more enumerated from other data. And Bucket Stream looks through certificate transparency logs. So like as new certificates are being created, it's looking at those logs to find DNS names of buckets. So it's pretty cool to look at, but it's a great recon tool. So this is a story. This is a few years old, but this guy, he basically related his story. I woke up in the next morning, had 4 emails from Amazon, and a missed call from AWS, about 140 servers running on his account. He only had S3 keys on his GitHub account, but he didn't realize through the S3 API, those attackers could spin up EC2 instances because he hadn't set his permissions right. And so his key was spotted by a bot that basically just crawls GitHub constantly for API keys. And so he found out the hard way that, attackers are out there, scanning constantly for credentials. So a lot of tools exist for credentials in GitHub. Time discovery from people have put there's this thing called the honey token, which I thought was pretty cool. I didn't put it in the slide, but essentially it's like a fake key that you're putting out there to see if anyone tries to use it. And so people have put those out there, and they found that within minutes of putting them publicly on GitHub, people are finding them and trying to use them. So a few of the newer ones I found were Trufflehog, Dumpster Diver. GitRob's been around for a while, and GitLeaks are good tools for scanning Git. So if you know the name of a development team, or you can start looking through repos and see if they have anything, either manually or using these tools to kind of scan for stuff. Recon tools. Burp Suite is kind of I would say it's good for phases 1 through 3 at least, if not 4. But if y'all aren't familiar with Burp Suite, it's a web app intercepting proxy. It has active scanning, a lot of features, stuff like that. But even passively, just looking at the traffic, and this is any intercepting proxy, you can see if API calls are being made to other systems, other ports, those proxies I was talking about, DNS names, entries that are coming up, and you can do this in a browser too. I mean, you don't really need an intercepting proxy, but I like to use it, and so it works well to see kind of what's being called when you are firing up an app, either that you've been given or that you found, and seeing how it interacts with AWS. And so look for also web frameworks. There's a lot of really good plugins that Burp has, and so it can identify things like struts, applications and other J2EE technology, Spring. There's a cool extension I found, and I threw it in here. It's not really an offensive tool, but since you're looking at stuff anyway, one thing when I do look at it, do pen test, sometimes I'll check and see if I think it's been compromised before. And so Minesweeper's a cool GitHub plugin that'll actually look for crypto miners and JavaScript and stuff like that. So it's kind of cool to load it up and see. I haven't had a hit on it yet, but I'm really curious to see if it'll ever fire off an alert saying this application already got a crypto miner inside of it. So Cloud Mapper. I'll run through some of these kind of quick just to make sure we have enough time. But this was originally created to make network diagrams. But as an attacker, you can use it to map out an environment. So if you do happen to have stolen credentials or were given credentials, you can basically use Cloud Mapper to kind of see visually okay, this is the way that it's laid out. It'll pull all the information out of AWS and tell you all the EC2 instances, everything else, and kind of map it out. Another one too is AWS public IPs, and you can get the associated public IPs. Even as an AWS user, I find it useful because sometimes I don't know what all the public IPs are, so it just pulls them all for you. So phase 2, we hacker cat is looks like he found something. He's really got his attention there. He's standing up. And so phase 2, starting to look at the vulnerabilities, starting to analyze, the results of all this recon, right? And so there's a cool tool called CloudFront. And CloudFront is an AWS CDN based on host header. So you set up your domains, and it'll tell you, it's like a virtual hosting for AWS, right? So you have to configure the CNAMEs. Basically, if they didn't configure certain ones, attackers can grab them, and then users would be directed to a malicious location, basically. So CloudFront is a good tool for seeing if that's the case and looking for misconfigured CloudFront domains. So also sometimes I'm given access to a Bastion host, which is just a box running SSH that allows me to log in as an unprivileged user, and then the DevOps teams use it to either run tools or shell into boxes when they need to. And so one of the things I always look for is local privilege escalation. Unix privs check will run a lot of checks to try to see if you can bust root on there. Also looking at things like patch level, kernel level vulns, things like dirty cow, things that might give you root access just to the local system. Misconfigured permission, shared keys, maybe somebody left their home directory readable or something like that, and seeing if you can get into other people's data on the local system. Passwords in history, mistyped, stuff like that. But that's a pretty good tool to use for that sort of thing. Again, Burp Suite, I won't go into too much detail here because as app security people, you may have used it or something like it, but going through active scanning, passive scanning, looking for frameworks, and they do have an AWS security checks plugin. So there's a lot of plugins that are in the Burp store, but there's also a lot of plugins that are just out there on GitHub. Also, one word of caution about, I guess, the Burp plugins is, I tend to trust one that came from the Burp App Store more than I would one from GitHub. But just if you do download one from GitHub, just kind of make sure it's not something that's just stealing your data that sounds really cool. So again, just running through. But there are some, there's another one, I think I had this slide in twice. So essentially, there's AWS Extender. And then there's the actual link for AWS security checks. So AWS security checks is part of the App Store within Burp, and AWS Extender is something that was just on GitHub. So I haven't had a chance to really play with it yet, but it looked interesting, looked kind of promising. Again, just looking at those frameworks, typical web app pen testing here, but you're using Burp in a different phase. So Claire is an open source project for static analysis of vulnerabilities in containers. It's pretty cool because if you either get access to, or again, kind of the gray box model where maybe you're given a Docker image or something of that sort, you can use Claire to do analysis of it to look for common misconfiguration, stuff like that. So it's kind of interesting, way to look for issues, configuration, or vulnerabilities, stuff like that in your AppC and Docker images. So Scout 2 is actually created by NCC Group. It's more of an audit tool, but again, if you have credentials, why not use it? It'll tell you if you have misconfigurations like no multi-factor authentication, and you could also use it to find additional accounts, so kind of escalate your privileges within AWS. This one I thought was really funny because of the name, but it's also, it's called Weird Owl, AAL, and that picture is actually on their GitHub. And it's like Weird Owl discovering. So I think that's one of his videos from back in the day. So essentially, if you have credentials but you're not sure what they can do, you can use Weird Owl to tell you. So it'll enumerate access to what services. It'll tell you, can you access Lambda, or can you spin up EC2 instances, or can you only do buckets? So once you have creds, you're not sure what they do, there's a quick way to tell. So Cloudsploit, it's kind of a framework following the Sploit theme. Requires credentials, again, big borrow or steal them, but it'll identify misconfigurations in an environment, and it'll give you a nice report too. CloudJack. CloudJack is a tool that looks for 53 CloudFront disjointedness. So here's an example. This one, it kind of took me a minute to wrap my head around. And essentially, so you have secure.foobar.com, right? Goes to foobar.aws.com. So within AWS, because it's aws.com, so they're deleting this domain within their control panel. They're like, okay, we don't need that anymore. It was for like this marketing thing for like 2 weeks, and we just deleted it. And so an attacker registers it. They see it's available on the AWS control panel. They register it. Well, your DNS is still pointed to that, which an attacker now controls and profit. And so you can see there's actually a video here, and I'm going to share the presentation afterwards, so you can be able to click on the links and stuff. And but this is a really good video. Actually, it was at an OAuth Austin meeting, going really into depth about the CloudJack tool. So it's a pretty cool tool to be able to look for those kind of misconfigurations. Typical stuff here, but one thing also I noticed is that a lot of these vulnerability scanners are really starting to also, I guess, face the same issue that I had, which is all these new services, things like that. And so a lot of them will actually let you input credentials and do some of these, audit type checks of your AWS configuration, what users you have, what permissions they have, things like that. And you can run them externally, or you can run them inside of VPC. You can also run them through proxy chains, but it might run a little slow. And I recommend to set up a virtual scanner inside the environment if you have that ability, either through stealing it or through setting it up beforehand. So phase 3, right? This is where you're actually getting into some of the good stuff. And you can see our cat here. He's got his hacker voice. I'm in. So that's where you really want to get into the system. So remember those creds we found earlier, hopefully, at this point. So using them manually with the CLI or plugging them into the frameworks. So Burp Suite, again, sky's the limit if web applications are found running. Typical OWASP type 10 type injections, SQL injection, that type of thing. Gain authenticated access if possible to the apps. If not, either, again, trying to get the credentials or trying to gain credentials. Maybe it's an application that allows you to create a user, open to the public, right? So even if it's a test user, try to create, because typically applications, as we all know, are going to have more stuff inside than exposed to the unauthenticated users, typically. Looking and seeing, is it calling microservices? Is it calling other stuff? Is there GraphQL on the back end? What's going on there? What's displaying the data? Where's it pulling it from? What APIs? What host names? And again, this basically takes us back to phase 1, because here we are testing the app, but we're still looking at what else is it calling, and are those targets too, or are those in scope? So then take each of those other systems that you found and work them back, try to exploit them. So as we've seen in the past couple of weeks, the SSH exploit come out, right? So everyone, secure shell, it's totally safe, right? Well, not always, right? And so even without this thing that's recently happened, it's happened before, but you can always do things like username enumeration, and certain older versions actually allowed it, or seeing if there is any kind of post on Stack Overflow and seeing what a developer's username might be. And so then maybe you have a valid username now, and you try to guess the password for that using brute force, right? Or looking for weak default logins, stolen SSH keys, maybe something you found through S3. But it's saying, these are not the droids you're looking for, essentially letting you in. I thought this was funny too. So this kind of describes the latest SSH exploit, and it's the guy at a job interview, and the interviewer saying, "I'm afraid you have not been selected for this position," basically saying, "No, I'm not letting you in." Well, he just says, "User all success." And so the guy says, "Okay, welcome aboard, you're hired, like come on in." And that's pretty much what's happening, right? It's just a simple mistake of the way that it's checking and sending it something that it would never expect, which is, I'm authenticated, let me in, and that's all that's happening there. And so as you can see, really think about if SSH doesn't need to be exposed externally, don't expose it. Wrap a VPN around it. Do something else if possible. But it's just one of those things that at least every AWS environment I've seen has at least one server running SSH somewhere, either it's Bastion or something, right? And so that's enough for an attacker to gain a foothold. So struts, right? A lot of the big high-profile hacks have, like the Equifax and all that, were apparently struts related. Struts is a great framework, MVC framework, but over the years, there's a lot of bugs that have come out. There was a deserialization one last year, and then this year was the namespaces issues that came out, both allowing you basically remote code execution on struts. And so back to earlier with the burp suite, you might not know that an application is using struts. From the outside appearance, it's not going to say powered by struts. You might only notice that if you're looking at the interaction with the back end or seeing some files in there, some directory structure, or the way that it takes requests, right? That's probably the biggest tell that if an application is a struts app, it's going to have like an action controller. Some people rename them though, they do different stuff. And so, again, if you can use something like this to exploit a struts application, then essentially gain a foothold and go from there. Tomcat, and then the application server runs on, right? Tomcat, and so Tomcat's a great application server, very flexible, but people usually tend to put the manager application on there so that they can easily upload WAR files and stuff like that. And so that's a really good way for attackers to get in, just the manager running itself. Either weak creds or default Tomcat. People leaving the examples installed that have stuff, or leaving some example struts thing. But this was funny because I actually was, for another conference, was working on a CTF, and I was purposely making a Tomcat server vulnerable. So I'm like, what are the stupid things I always see people do? Okay, yeah, like Tomcat, I'll just set that and somebody will find it, Well, somebody found it. Within a day, somebody was uploading web shells to my vulnerable CTF box on AWS, and I found this, and it was interesting. So apparently it was just, I don't know why they had several different versions of the same web shell, but they had a whole interface that they were logging into, and not sure what they were doing, but I wasn't going to leave the server up to find out. So just, took as much information, took a snapshot, got rid of it. But it's something I do want to go look at more later and figure out what the heck they were doing. So LFI, so like local file includes, can't tell you what the application was, but there's an application used to manage billing across clouds. And it was like a web goat or something, I swear. Like this application, it had so many bugs in it. I was like, are they serious? Like, did they mean to do this? So anyone could create an account, and then you could log in, and there was a functionality to like view log files, like billing logs or something. And so with that, and because it was running as root, you could essentially read SSH keys, and then shell into other boxes. And then those other boxes had keys to get back into that box, and it was just lots of fun for everyone. But yeah, I can't say what the name of it is because it's still out there. But it's just one of those things where if it has an option to disable people creating accounts, and it only has a certain fixed amount of users, just disable that functionality so people can't go and create themselves an account and start poking around. So XXC, so XML external entity expansion. And again, these are just some of the things that I found. There's other ways in to gain a foothold, but looking for things like this, which will essentially allow you to send a request, and you could send a request anywhere, right? People typically use XXC to steal credentials if the server has FTP credentials, get a request from something else. But the cool thing about AWS EC2 instances, they have this metadata server. So it's running by default. This particular URL isn't always running, I found. It's only when you add a certain role to the EC2 instance, it then stores the credentials there for anyone to grab, remotely or locally. So here's an example, like it's concatenated or truncated, sorry, but essentially, if you can either internally or externally through something like XXE pull this URL, you're able to get credentials out of a system. So things like proxies, you could do that with a proxy also. It's really interesting. This is a role, so you have to essentially create a role and add it to an instance to allow this to happen. So it's not on every HTTP instance you have to do this, but a lot of people do this. For example, if they're auto-scaling, they might allow this to happen so that the auto-scaling system can control deployment of EC2 instances. GraphQL was something I came across. I was like, what is this? This is weird. Like, why is this database like just open and things are out here? And it really took me a while to wrap my head around it. But essentially, it's a NoSQL database, and a lot of people are using it in a way that it's not the database storing the data directly. It's like being fed data. So, again, it just depends on the deployment, but it was a really weird thing. You can still do stuff like parameter tampering, insecure direct object references to essentially grab data you're not supposed to have, changing a user ID, stuff like that. So it's like what's old is new again, because now they're moving where the data is, and so people aren't always checking that you're only supposed to see data for the user that you are. So logic flaws are a big thing there, and it mostly comes down to configuration and authorization checking. But NoSQL injection and improperly implemented authentication are also things that I've seen with GraphQL. So just saying, hey, anybody can just grab our data. So the front-end web app is saying, who are you? And you have to authenticate. But then this GraphQL thing in the back is just, oh, whoever asked me can get data. And so stuff like that. So Kubernetes, I'm still digging into this. If you're not familiar with Kubernetes, it's an orchestration system for containers. It's kind of a cloud within a cloud. And it's really meant for containerized applications to be organized in a better way and to also auto-scale. So many developers, right, as you're learning, you tend to use templates for their initial setup. And this can become a bad habit with insecure defaults. So you can use this example to actually get up and running. And here's another example with a quick start with the template, but as you'll see, the problem is that by default, it's letting everyone access the API. And so people are using this template, and they're like, oh, API access, just leave it open, because that's how the default said in the template, and that's how I'm learning it, so that's how I'm deploying it in production. I don't want to mess with that, because it might break something. And so they're essentially giving everyone the ability to execute commands on the containers if you're doing that, if you're allowing access to the API port. And that's either externally or even within the containers. Like say you have just one container. It's kind of like the old analogy where you didn't want to have services running as root. Well, you don't want to have a service like a Tomcat or something running struts. And if you get a shell on that box, you don't want them to be able to get root on that box and then get to everything. You want to containerize it as much as possible and isolate them. And so you don't want them to have access to the API port and be able to take over other containers just because they took over one. This is an interesting one from HackerOne. Somebody found a server-side request forgery that they combined with accessing the API to gain root on like every container in this environment. Also, you can look for misconfigurations with kubebench. You can run it inside a container, and it uses CIS benchmarks. There might be a bunch of low severity issues by themselves, but when they're combined, you can use them to either pivot or do privilege escalation, things like that. Lambda was really interesting too. Command injection attacks I mentioned. Abusing persistence. So a Lambda function is supposed to run, and then that's it. Some people have found ways to kind of have them hang around so you can run that mmap scan and do other stuff that you want to do, abusing network access or trust. And James Wickett actually put together this Lambda Hack. It's like a web goat for Lambda. And it's a fun way just to play with Lambda and get started. And see how that type of exploit might work, and then see if you have anything similar running in your code. So phase 4, post-exploitation. So once you're in just kind of sneaking around and saying, well, what else can I do? Pakku is a really cool framework. Actually saw a talk by the guy that wrote this, and he's still working on it. It's very much a work in progress, but it has a lot of functionality there. I haven't even got to try like a tenth of it. But essentially, you can do stuff like enumeration and privilege escalation within AWS. So like say you have credentials and you can only do Lambda functions with them. Well, he's developed and come up with some ways and put them into this framework where you can essentially escalate your privileges within AWS. Almost if you think of AWS as an operating system, which it's really becoming, you're essentially escalating your privileges within AWS. Data exfiltration, maybe you're not sure how to get all the data and cool stuff out of RDS, so it helps with that. And it's Python based, so you can always add, expand, change it, stuff like that. Metasploit, our good old friend Metasploit, still there and still in the game. Tons of stuff here. Once you've gained access, I still like to set up an interpreter session. If you're not familiar with it, you can use it as a bind shell or reverse shell or different protocols, different ports. Maybe they're filtering outbound traffic. You can change it, have it go over DNS, whatever you want to do. In Metasploit, you can really use it for phases 1 through 4 too. If you want to do recon within Metasploit, you could. If you wanted to do vulnerability analysis within Metasploit, there's plugins for that too. But I tend to use it, the other way, where I'm using it mostly for either exploitation and post-exploitation, or maybe even just post-exploitation. But there's a ton of tools in there, and it's being added to all the time. A lot of scripts to check vulnerabilities. So if you're curious, you're not sure, am I vulnerable to the struts thing? Well, let me check. There's a script for that, right? Exploits for almost everything within the past 15 years. And it really shines, like I said, when it's used for post-exploitation. One of the plugins, as an example, AWS Create IAM User. And essentially, it allows you to, escalate your privileges, again, within AWS. So, Nimbus is kind of interesting. I haven't used it much. I kind of played with it a little bit. Fingerprinting and exploitation of AWS environments is what they describe it as. But I found the most useful features were the ability to dump credentials, add users, and inject into Celery message queue, which I actually haven't run into Celery yet. So it's only a matter of time. I'm actually glad I found this tool, because I'm sure that there's going to be some app, and there's going to be like, just, I typically ask for some kind of background on how the app's put together. But if I don't, you can find out, and it's only been a matter of time before I see something that uses this Celery message queue. And so it has the ability to inject messages into that. So again, with post-exploitation, one thing I always do too is if I only have access to, like, say, a bastion, and they don't allow me to install anything on there, well, I can use SSH, either using proxy change or shuttle. So proxy change, you can essentially set up an SSH tunnel, configure proxy chains, and then you can run your apps through it, so like Nmap scans, whatever you want. You can also use shuttle. Shuttle is really easy to use and get started with. Doesn't work as well as proxy chains for scanning, gives you really weird results. But it's easy to get started. Like if you need to connect on a particular IP or something, and you just want to, essentially give yourself an SSH VPN on the entire, class 8 10 address space, it's a really easy way to do that without having to know what those IPs are, and then connecting to the port from your outside system through SSH to the inside. AWS Pwn. So again, a lot of tools, but really what I want to kind of convey is the techniques behind these tools and what they're doing, and things to help you as a defender too, because you're trying to understand what these attackers are doing, and that's what a lot of these tools emulate. And so AWS Pwn helps you to gain a foothold, and then disables CloudTrail logging. And so like if you were doing purple teaming where you had some active defenses in place, and you wanted to hide your tracks, you can actually turn off CloudTrail if you have the credentials to do that, right? And if you don't, then you elevate privileges, and it also has some built-in recon functionality. So again, this may be something, if you do find credentials early on, something to look at. kind of seeing what else is there. Some of these tools don't really fit into one phase, but they do, in my mind, more fit into one phase versus another, and this one I think would be post-exploitation. So, what have we learned? There's the kid there with his keyboard ready to learn. And what I really want you to take away from this is how to see your systems from an outsider perspective. I know as an admin, as a developer, it's kind of hard for me to step outside of the thought that, okay, well, I can't really look at this as an outsider because I have access. When you kind of like, when you have root in a box, you're like, how am I supposed to pen test this if I already have root? Well, take that away from yourself and look at it as an outsider and, test your own systems. You don't have to be a official pen tester as long as you have permission. There's some really good tools in here to audit stuff. And again, this type of auditing isn't just a checkbox like two-factor. It's like looking at all the vulnerabilities, looking at the bugs, finding the flaws, and figuring out, what really matters to an attacker, prioritizing it in a way and say, okay, well, obviously, if credentials are leaked, that's pretty important. So maybe that takes higher precedence than something else, than some low-level vulnerability, right? And then maybe you need to change your AWS keys. So clearly define the scope also, and you can just focus on one area, right? You don't have to look at everything and do everything. Maybe you just want to look at your Kubernetes. And internal pen tests at AWS are a thing. I kind of think it's the new internal pen test is, this type of pen test, because in the old way, an internal pen test would be, well, we gave this administrator access to this one system, or maybe it's a desktop user. We gave them administrator access on their desktop. Well, that administrator access doesn't mean that they should have access to everyone's desktop and on the file server and the Exchange server, right? So if you have a DevOps person that is only supposed to have access to one system, an elk stack, but through that, they're able to elevate their privileges, exploit other systems inside because nobody's ever looked at them or scanned them, and they're like, haven't been patched in a year. That's not a good thing, right? Because then essentially that developer, you're giving him access to everything. So I think of this AWS pen testing almost like I would an internal pen test, except that, you can't go sit inside AWS and plug your laptop in. You can't hang out where the smokers are and walk in there. It's locked down pretty well. So the way to do that is simulate an attacker by using the credentials and using the access that an attacker would get. Assume attackers are going to steal your credentials at some point. They're going to get through the crunchy outer shell and into the softer inside to start poking around. And so if you just simulate that, assume your credentials might get compromised, you can build your defense in depth and really start to look at it through the eyes of an attacker, even though you're using credentials. So I give some additional references here. I saw a really good talk by a guy named Karthik, and he was a good inspiration for me on the Kubernetes security. So his slides are here, and then also some stuff on DevSecOps and the Cumulus toolkit, which was I believe that stuff's rolled into Metasploit now. That's why I didn't include it as a standalone tool, because I think it's all rolled into Metasploit. So thank you all. I know it was kind of fast and furious, but there's a lot of ground to cover. And again, I'm going to share this. So it's really not meant to be an all-inclusive thing. It's just some of the stuff that I found and kind of my journey, what it's been so far and where it's going is just digging into all these topics more. And whatever AWS decides to roll out next week, I'm sure I'm going to have to learn that too and figure out how to own it. So that's all I have. Thanks.